Now we're going to look at power of a power rules. So this is actually when we have an exponent raised to another exponent. And it's always going to look like this. So like on number 1 here, we have x to the 4th, but then this x to the 4th is raised to the second power. So let's first look at what this means, and then we'll look at how to solve it. So x to the 4th, here's an x to the 4th. Because that's raised to the second power, that means I have x to the 4th twice. So I have an x to the 4th, and I have another x to the 4th. And then each of these means I have 4 x's, and then I have 4 more x's, and then I can look and I have 8 x's altogether. So then our shortcut for this is that we can multiply the exponents. 4 times 2 is 8. And that's going to take a lot less time than writing out all these different things. So on this one, number 2, this means I would have 4 to the 3rd 3 times, or the shortcut is 3 times 3, or 4 to the 9th. So we can write over here, we have power of a power. We multiply the exponents. And when we do this, we need to make sure we multiply every exponent that's inside the parentheses. So when we get to number 4, we start seeing problems like that. So number 3, we have 2 times negative 5 is actually going to be 2 to the negative 10. However, we can't leave an exponent negative, so I need to simplify more. Remember how to do negative exponents. We think of it as a fraction, so I can put anything over 1 to make it a fraction. Then the n has a negative exponent, so it needs to move. It's in the numerator, so it needs to flip, go down to the denominator. And when it does, it becomes positive. Then I can't have nothing in top, so we have a 1. So if you just put n to the negative 10, you're going to get some credit, but to get full credit, you need to make sure you simplify that negative exponent. And technically here, 4 to the 9th, we would actually need to solve that and put in your calculator 4 to the 9th power is, and write out your answer. For the sake of time on these notes, we're just going to go over this exponent rule and not typing in the calculator. Okay, so starting at number 4, this is where you have to multiply all numbers, multiply all exponents inside. So I'm going to make that note here. Multiply all inside exponents by the outside exponent. So it's not distributive property, but if it helps to think of it that way, that might be helpful. To think of it as distributive property for exponents, kind of. So we're going to take the outside and multiply by every exponent on the inside. What's tricky though is this y. It looks like that y doesn't have an exponent, but it has that hidden 1. So we don't want to forget to multiply that. So I'm going to multiply 3 times a 3. That's going to become 2 to the 9. And then 3 times a 5 is going to become x to the 15. And 3 times that hidden 1 is going to be y to the 3rd. And again, on a quiz or test, we would actually want to do 2 to the 9th power. Tell me what that is. But for right now, we're just going to leave it like this. Number 5. I'm going to do this part first, and then I'm going to do this part. So this 3 is only on the outside of this parentheses, and the 2 is on the outside of only this one. So it's like 2 problems in one. This 4 does have a hidden 1, so we're going to multiply 3 times 1. That becomes 4 to the 3rd. And then 3 times 5 becomes y to the 15th. Now we're going to go over here. So this 2 is only outside these parentheses. So we can't multiply this exponent of 2 times that 4 on the y, because it's not outside those parentheses. And the a has a hidden 1 again. So 2 times 1 is a to the 2. And 2 times 6 is b to the 12. Now technically, when we have a bunch of variables like this, the proper way is to write them alphabetically and also take into account their exponents, but we're going to get more into that in our next chapter, so we'll just leave it alone for now. And again, I really should calculate 4 to the third on a quiz or test, but for the sake of these notes, we're just going to leave it for now. Number 6, so this 2 goes with that parentheses, and this 4 just goes with that set of parentheses. So we're going to do each one separate. But in this one, both the A and the B have that hidden 1. So 2 to the 1 is A to the second, and 2 times the 1 on the B makes it B to the second. Now I'm going to do the second part over here. 4 times 2, that makes that A to the 8, and 4 times negative 2 makes that B to the negative 8. Unlike the other problems, I have some matching bases. I have an A and an A. So we can use one of our other exponent rules, because these are all actually being multiplied. We just don't see the multiplication sign, but they are being multiplied. So when we're multiplying and we have the matching base, we can actually use that shortcut and add those exponents. So 2 plus 8, that actually makes that A to the 10. And I can do the same thing for the B. B has a matching base. We're multiplying, so we can add those exponents. 2 plus negative 8 is B to the negative 6. But we're not quite done yet because we can't leave that as a negative exponent. So anytime I have a negative exponent, I want a fraction. So I'm going to make it a fraction, putting it over 1. But then I'm going to leave the A alone because it already has a positive exponent, so it can stay where it's at. But that B has a negative exponent, it needs to move. It's up, so we're going to move it down to make it B to the positive 6. So this would be my final simplified answer for that problem. And then the same is going to be true when we start doing division. We're going to treat that in the same way. We will take the outside exponent and multiply every exponent on the inside. And we'll look at that in a separate video.